Let's see. So what's underneath has to be greater than or equal to 0. Yeah, x should be less than. This is the one that I made a mistake on last time, right? It was the same thing. X has to be less than when we switch this around, x has to be less than or equal to that 3/5. So this should be negative infinity to 3/5. That's correct. Yeah. Correct. Anything else on this page? Oh, Sophie.
Can you explain number
5. Yeah, okay, so there's two things happening here, right? You've got a square root in the top, and you've got a fraction that's got a variable. So the square root in the top, you're going to set greater than or equal to 0. That's this work here. Add the 5, divide by 4, and I get x is greater than or equal to 5/4. So if that was just it, if the numerator was just that, then I'm done. But because the denominator also has a variable in it, this cannot equal 0. So you can either add the 16 square root, get the plus or minus, or you could have factored that. You could have done difference 2 squares, x plus 4, x minus 4. Either way that you get, x cannot equal negative 4 or positive 4. So if I put this on a number line, right, the smallest is negative 4, then positive 5/4, and the next one would be positive 4. The negative 5/4, or sorry, the positive 5/4 is a greater than or equal to. So this would be like a bracket pointing to the right. But it can't be a negative 4, which means it's an open dot here, and it can't be a positive 4, which means an open dot here. The negative 4 doesn't matter because it doesn't overlap. I literally just don't completely ignore that side of the equation. But on this side, there is an overlap here, and it's basically saying it's everything except that positive 4. So I would go from 5/4 up to the 4, put a parentheses on the 4, and then 4 to positive infinity. So that's how you're skipping. This is how I would show I am skipping that point because I'm saying up to that point and then after that point, but the parentheses say don't include that point. So that's how your not equals is going to show up. Kevin. Any other things, any other questions on the first page before I get to that one? Okay. Samuel, you got a question?
So what is it that you do in both graphs, like 2 graphs? And the other day you would...
Yeah. Okay, so 6, right, Kevin? Yeah. Yeah. All right, it says graph the function and then find the domain and the range. So this is our transformations, right? So the first thing I know is that it's a squared, which means it's a parabola. And then this is right 1, and this is up 3. So on my answer sheet, which you're going to get an answer sheet, I would go right 1, I would go up 3, I would plot my point, and I would make my parabola point it up because it's positive. Then it says find the domain and range. So once you know what that looks like, you can either find domain from your equation or from here. If I look at my equation, there's no variable in the denominator, and there's no variable in a square root, which tells me my domain has no restriction. My domain would be all real numbers, negative infinity to positive infinity. Or you can look at your graph. If I look at my graph, those arrows are going to point left, they're going to point right, they're going to keep going in either direction, so it's all real numbers. The range starts here and goes up. So it starts at the y, which is positive 3. It's a solid dot there. All your transformations are going to be solid dots. And then it points to positive infinity, so it would be, or it points out, which would be positive infinity. You're welcome, Richard. So if the negative is here, it flips your graph upside down, right? So I would still go right 1, I would go up 3, and then I would point my parabola down. So that doesn't change your domain. Domain is still negative infinity to positive infinity, but it does change your range, right? Because now you're going bottom to top. So it starts at negative infinity, it goes up to 3, and it would have a bracket on the 3. So it changes the order of the range.
Question, what's negative parentheses, negative x minus 1?
Inside.
Yeah.
So they exist, but they're not going to be on your test. Yeah. The negative would be out here.
Right.
Yeah.
Oh, it
just flips it upside down. Yep. So like this one, now we've got our absolute value, right? So the negative is upside down. The minus 3 is to the right 3. The minus 4 is down 4. And then you draw it. This is the transformation one. So on the test, it even gives you like the parent function, and then it shifts it. Most of them. I think there's like 3 questions with the transformations. 2 of them give you like where you'll see the original one, where it would be like, here's my original one, and then there's my, it's actually dashed like that. You'll be able to tell because the parent function is the parent function. And then you'll see it shifted. So some of them have both graphs on there. Any other questions on this page? Richard?
Number
9. All right, so 9, take it apart, right? The negative means upside down. The plus 3 underneath goes left 3. The minus 4 goes down 4. So if I'm drawing it on an answer sheet, I'm going left 3, I'm going down 4, and I'm pointing my square root, which normally goes like this. I'm pointing it upside down so it looks like that. Domain, now there's a restriction, right, because there's square root. Domain, if I look at the graph, is from -3 to positive infinity, which is the same thing I would get if I looked at my equation. And the range is from negative infinity, because it's pointing down, up to 4, -4. Any other questions on page 2? Okay, page 3, a lot of the equations of the line stuff. Yeah, again, 19. So we're going to graph. I would just put it in slope-intercept form. I feel like that's the thing that you're most comfortable with. So if you take this and I get 3x minus 4y equals 7, negative 4y equals negative 3x plus 7, divide by -4. And I get y equals 3/4 x minus 7/4, which is -1 3/4. So I would go to the y-intercept, which is -1 3/4, and then you could just count up 1, 2, 3 over 1, 2, 3, 4, and your point would be on that. Like, the good thing is if this is multiple choice, you're not going to be that far off. You would just draw your line. What the work is here is just using the intercepts to graph it. So if it's in standard form, it's often easier to use the intercepts. If I plug 0 in here, I get -4 equals 7, so y would equal -7/4, and that's one coordinate point. And then if I plug 0 in here, I get 3x equals 7, and I get x equals 7/3, and that would be your other intercept. And then you just connect them. So you can choose how you do that, either way. Any other questions on page, what are we on now? 3.
Number
17. Okay, so it says find the equation of a vertical line through point 27. So you have to know vertical means x equals, and then just grab the 2. Yep. That's hopefully those don't get you, because there's not, like if it's undefined, there's no way to plug that in. So you got to know verticals x equals, horizontals y equals. Okay, 4th page. Sophia, 22? 22 is find the symmetry. So remember, if you're testing for symmetry, that you're going to plug in a -x to test for y-axis symmetry. So actually on your test, y-axis is the same thing as even. It's going to ask in terms of even, odd, and neither instead of symmetry. But y-axis, same thing as even. And this is where you plug in a -x. And it goes back to the original. So if I plug in a -x here, I'd get y equals -x squared minus -x plus 1. Simplify what you can. So -x squared is going to go back to positive x. Negative and a negative makes this a positive x plus 1. Then you want to compare this to your original. Is it the same? And it's not, right? 2 of the things are the same, but that x in the middle changed sign, which means it would not be y-axis symmetry or even. Then the question is, if I plug in the -x, did every sign change? And only 2 of them change. So then it's not odd either, right? So origin is the same thing as odd. And that fails too, so then it's neither. They're going to be in function notation, so they're going to say f of x, which means they can never be symmetric to the y-axis, which would be the 3rd type of symmetry. And that's if you plug in a -y. Yeah. This one? This would be if you plugged in a -x. So the rule on origin really is that you plug in a -x and a -y. Like if you're just doing symmetry, if you're not looking at even odd for functions, you plug in a -x and a -y. And if everything goes back to the original, then it's symmetric to the origin. But because we're doing these with functions, this is always going to be an f of x, which means it could never be symmetric to the x-axis, which means you can also do what we've been doing, just do -x and see if everything changed. No, you can do it the way we've been doing it. So plug in the -x. If everything goes back to the original, right? Plug in -x. If it goes back to the original, then it's even, which means y-axis symmetry. If everything changes, then it's odd or has origin symmetry. And then neither's neither. Yeah. Yes. So remember, this y-axis symmetry means you can literally draw like an absolute value function, y-axis. If you can fold it along the y-axis, if you can fold it like a hot dog and it overlaps, that's even. If it's got origin symmetry, it means whatever's happening on the top right is happening on the bottom left. So it literally would be a down and over situation, okay? Or the other way around, like if it was this way, it would also be odd because it could be down and over. And if you think about that equation is f of x equals x to the third, like what I just drew. If I plug in a negative x, it becomes negative x to the third, and everything changed, which makes it odd. Yeah.
So the only work we have to do is just
Plug in the negative x. Yep. Or use your graph. Yeah. Yeah. 24. Yep. So 24, I plug in negative x minus negative x. This is negative x to the third minus a negative x becomes plus x. So it doesn't go back to the original, right? And compare these two, the signs are different. Compare these two, the signs are different. That means it's odd. 25 you said, right? Okay. 25, you're actually not going to graph it, so don't worry about the graphing of the piecewise function. That's the part. Yeah, I put it in the instructions, didn't I? Like, you don't have to graph 25. You're not going to have to graph it. You're just going to have to find the values. That's the part we skipped. That's 2.5. Remember, we skipped it. Yeah, so if it's f of 3, then 3 is less than or equal to 3. So I come here and I plug 3 in. 3 squared minus 1, 9 minus 1, that's 8. And then f of 4, it's bigger than 3. So I come here and I do 4 to the third, which is 64. You won't have to graph it. We skipped that section for now. Any other questions on, what am I on, page 4? Yeah.
So we don't have to know symmetry for the test.
You need to know it in terms of even odd.
So we don't have to like know the origin of the y-axis.
Right. Let me double check 100% because now I'm starting to second guess myself. Yes, it should. Decreasing is from negative 5 to negative 2.
And then also for the constant shouldn't have brackets instead since it's like a solid line and solid dot.
So because it's shared, it can't, right? Like this one is shared. It's got to stop and not be shared by anything else for it to either start, like all the way on the left, it would have to start constant, or all the way on the right, it would have to stop constant. If it's shared, because that point we're saying basically if you put a bracket there, you're not only saying that it's constant, but you're also saying it's included. I mean increasing, and you can't do that, right? The same point can't be two things. So if it ended, if over here there was like a this, that's the only time you're gonna get a bracket. Or if it started, that's gonna get a bracket. No other time. Yeah. The increase and decrease, domain, range, all of it, right? Yeah. All right, so domain, I'm gonna go left to right. Furthest point left is this one, which is negative 6. It's open, so it gets a parentheses. Then it continues on over here. This is open, but then it starts a new one, which means that point is included in my domain. I don't have to stop start. Then it keeps going. Same thing here. One's open, one's closed. It's still part of my domain. Open, closed. So there's no gaps there, which means my domain is literally going from the furthest point left to the furthest point right, which is 7. They're both open dots, so they both get parentheses. Yeah, only if there was a space in between. Or if by chance, like these were both open dots, then I would skip that. So it would go from negative 6 to negative 2 with a parentheses on the negative 2, and then I would start at negative 2 again with a parentheses and go on to. Correct. Then we've got range. So the lowest y here is, there's all of these, but they're all at negative 1. Now some of them are open dots, but then here it's a solid dot, which means I actually include that negative 1. It's part of my range. And then there's a space over here, but this takes over that spacing, which means that I include all of that all the way up here, all the way up here till here, which also continues over here. So the highest point, there's no breaking places between the low and high in which there's no overlap, which means it's all one range and it would stop at 5. And because it's an open dot, it would get a parentheses. because this one's open, this one's open, this one's open, but this is solid, so 1's included, or -1. All right, then you get increasing, decreasing, constant, right? So she kind of like highlighted what would be increasing and decreasing and constant. Remember, you're moving from left to right. So this first part is increasing, so it's increasing, and it's the x values from -6 to this part here, which is -2. They would both get parentheses because increasing always gets parentheses. Then it changes direction and it comes down here, so that would be the decreasing. From -2 to +2, again, decreasing always gets parentheses because it can't be. A point itself can't be decreasing. Then it's constant. From 2 to 5, but those are both shared by another point, and it's an open dot, so it would get the parentheses. And then it changes again to increasing, so I come back up here, and it's 5 to 7. And again, increasing can't have brackets. Kiara.
If the constant was closed off, but they still share another point,
Then it's still a parentheses, because you're saying you can't say one point is both constant and increasing. And they couldn't both be solid dots, because then it fails your function test. Right? Because then a vertical line, so you won't see that, because then it's not a function. Yeah, sure. Samuel.
The ones decreasing there, one of them was like open dot. Not to like.
Well, decreasing and increasing is always parentheses, open dot or not.
No, I'm talking about domain. Like,
Oh, domain?
If the one where it's decreasing.
Yeah, so like if this one was open dot and this one was open dot, right? Now my domain goes from -6 to -2, parentheses on -2, starts again at -2, and goes to, what was the highest point? 7. Because now you're saying it's all those numbers, but I can't include that number if they were both open dots. Sophie,
So it has to be a closed dot and an open dot for it to be.
for it to be overlapped and keep going. Yeah, You're welcome. Yeah.
Can you explain the range on the second?
On the second one, sure. Okay, so lowest point, right, is down here, which looks like it's 4.5. So 4.5, it's open dot, so it's a parentheses. And then there's a gap there's a gap here, but this line overtakes that. It's still going all the way up. Then it stops, right? But over here it takes over and it's still going up. The only time from bottom to top in which there is no line or point is the gap in between these two, which means my range has to stop at -1. It's a solid dot, so it gets a bracket. And then it starts up again at 0, and then it goes up to 4. 4 is the open dot, so it gets parentheses. So there's it. Like if you literally go from bottom to top, there are points or lines from here all the way up to here. But in this section here, it skips. So that's why your range has to start and stop. Yeah.
So what if like even if another dot there was open, like whichever one you change?
Like give me which dot you're talking about.
That one always up right.
On the right, this one.
Yeah.
So this is open, but look, there's a solid dot in the same spot on the other graph, so that changes nothing.
But then did you say if there's two closed dots on the same line, it fails?
That's vertical. So if there was one here and one here, the vertical line would fail. But it's not going to trick you like that. It's not going to be like find all that information, and you're going to be like, oh, it's not even a function. I won't do that. You're welcome. Other questions? Okay, so I'll go back to 2, but I'm going to actually work 3 out, right? So 3 says f of x is the square root of x plus 3, and g of x is 2x minus 5. So I'm going to first do f of g, and then I'm going to come back and do g of f. So the g goes into the f. This one goes over here, so I get the square root of 2x minus 5 plus 3, and I get the square root of 2x minus 2. That would be the combined function, so that's one part. Then it says find the domain of this. So I have to find the domain of this guy. This has to be greater than or equal to 0 because it's underneath the square root. 2x to be greater than or equal to 2, and x has to be greater than or equal to 1. So domain on that would be 1 to positive infinity with a bracket on the 1. Then I have to go back to the variable on the right and see if there's an additional restriction. Go to g of x there's no square root, there's no denominator, which means there's no additional restriction, and that this is the only domain I have to worry about. Richard.
What there was.
If there was, so that's the next one. So if I do g of f of x, now I'm taking this and I'm plugging it in here. I get 2 square root of x plus 3 minus 5. I can't simplify that any further, so this is actually my combined function. And then there's a restriction because I got the square root. So x plus 3 has to be greater than or equal to 0. X has to be greater than or equal to negative 3. Domain of just that would be negative 3 to positive infinity with a bracket on the negative 3. Then I go back to the f of x, the one on the right, and see if there's an additional restriction. This is my f of x. It's actually the same restriction. So I get to keep this domain. If it was a different restriction, then I look for the overlap of the two. So like if it said x has to be greater than or equal to negative 2 and x has to be greater than or equal to negative 3, I keep the negative 2 to positive infinity. So it's always combine them, see if there's a restriction on the combined one, and then go back to the letter on the right and see if there's an additional restriction. So 4 says find f over g, and then it says, and then find its domain. So f over g becomes the square root of x over 4 minus x squared. And then I want to find the domain. So what's the restrictions happening on square root of x over square root of 4 minus x squared? How do I set up a restriction? Sophie.
The top greater than or equal to 0.
Good. And the bottom?
Not equal to 0.
So close. It is not equal to, but it's also a radical. So it's greater than 0. Does that make sense? If the square root was not there, it would be not equal to, but the square root's there, which makes it complicated. Yep. 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 So the top is just x is greater than or equal to 0, right? So on my number line, it would be 0. It'd be a bracket. It'd be pointing to the right. The bottom is, again, squared and the square root, which means I would solve it. 4 would equal x squared. X would equal plus or minus the square root of 4, which is 2. And then I would set up that number line, negative 2, positive 2. And then I'd plug in 0 into this statement. So 4 minus 0 squared is greater than 0. 4 is greater than 0. So the answer for just the bottom is parentheses on the negative 2 and the positive 2 shaded in between. Now I got to overlap that with what's on the top. So the top said 0 to the right. The bottom says negative 2, 2 in between, and we only keep where it overlaps. So I only keep from 0 to positive 2. Now 0 gets a bracket, positive 2 has a parentheses. For 5, f plus g would be x to the third plus 2x squared plus 3x squared minus 1. And I would just simplify by combining my like terms. So x to the third plus 5x squared minus 1. That's my sum. And then it says find its domain. So is there any domain restriction on that statement? No. Domain would be all real numbers or negative infinity to positive infinity. And then the last one is 6. Now it's the sum again, but it's the square root of x plus 2 plus 3x minus 2. Can't be simplified, so that's the actual sum, but then we check its domain. The square root of x plus 2 would have to be greater than or equal to 0. X would have to be greater than or equal to negative 2. So my domain is negative 2 to positive infinity. So again, I think this is what you struggled with the most, but it's not the only thing on your test. So you can't just focus on the domain restrictions. It is important, but you've got your transformations, you've got your lines, your slope equations, you've got your vertical lines, horizontal lines, parallel, perpendicular, like all that stuff is still a big component of your test. So you just want to make sure you're prepared for all of it.
Why don't you do the other part with the 3x minus?
Because there's no restriction too, right? Like there's no square root and there's no variable in the denominator. Those are the things you're looking at.
So you wouldn't do like the negative infinity.
It would be that for that part, but the domain is the overlap of all those restrictions. So as soon as you put the restriction that it's got to be greater than negative 2, it overtakes the negative infinity to positive infinity. Sure. Tanya.
For number 1,
The second one? Sure. Okay, so did you get to this point? Okay, so that's the combined, right? I took the f, I plugged it into the g, I got the square root of negative x squared minus 6x. So then the domain there is that whatever's underneath the radical has to be greater than or equal to 0. As soon as you see the squared and the non-squared, you're going to have to factor. So I took out a negative x, and I made it x plus 6. Split and solve that, and you'd get 0, and you'd get negative 6. Those are your test points. So we can't do 0 this time, but I just picked 1. I plugged 1 in up here, right? So negative 1 squared minus 6 times 1 should be greater than or equal to 0. I get negative 1 minus 6, and negative 7 is not greater than or equal to 0. So I know I'm ruling out the outer 2, and I'm keeping the inside. So negative 6 to 0 would be the domain on that one. Then you have to check the letter on the right. So I go back to my g of x, or my f of x, sorry. And my f of x, this was one, right? My f of x is just x plus 3. There's no additional domain restriction on that. So my domain is just negative 6 to 0. You're welcome.